Hey guys, in this video I will show you how to assemble the magnetic paddle shifter. This is a 3D printed part. The plans are going to be posted alongside this video. So all you need is a 3D printer and then you can create a magnetic paddle shifter just like that. There are two variations of this right now. There's one for this type of switch, the one with the metal lever on top here. The advantage of this design is that the tolerances are more, they're not as tight. Due to the lever, there's a lot more, there's a little bit of more room for error. So if your 3D printer is not as accurate, or if you have any problems with the other design, this might be the way to go. I did look up the data sheet, and these type of switches are not rated for many cycles, probably due to the hinge part. You have more parts in here that may break, or one more part. So what I did, I created a variation that is now compatible to this type of switch. It doesn't have the lever anymore, you just have that little push button on here. As you can see, it's a really tiny little button on top. So everything, the design has to be a lot tighter. Your printer needs to be pretty good to get this working. I will be showing you both of the units inside is pretty much the same. It's just the main difference is how deep the switch sits in the pocket. This one's for the lever part and this one's for that little button part. I've already prepared this one, so I will show you what needs to be done to get this unit working. Once I have this prepared, I will also finish assembling this one here with the lever, so you can see both working, and they're both very easy. This is 3D printed part. You're going to need to do a little bit of cleanup since the parts are designed to be a little tighter so you don't have as much slop in the part once it's actually done. So let's get started. Okay, since this is a 3D printed part and the 3D printed part is just loops of plastic that the printer puts down, the surface in here is not very smooth. So what we need to do is just grind a little bit of material away. And if you feel it, you can actually feel the layers. So you just need to grind a little bit of plastic away until it gets really smooth in here. This just ensures that the lever part doesn't rub or get stuck. So let's just remove a little material. And the way this part is designed, this is thicker. There's more space in here, so you really shouldn't have to remove any material. Or just sometimes you have little, like tiny little plastic dots. I don't know if you can see it on the video. There's a little lip here. You may need to remove that, but other than that, there should be enough room. So just mostly focus on this side right here and on the other side. It's these parts that need to be really smooth. So let me just get started. These parts are printed in PLA, 0.25 millimeter layer height. You should probably use a layer height that is around that. 0.25 is probably a good idea, since all the dimensions in here are metric and they're designed with a 0.25 millimeter layer height in mind. Especially if the switch pocket is a little tight. So, clean this up real quick. And it doesn't need much. It's already much smoother than the other side. It just gets rid of those little layer impurities or the differences. And then if you print in PLA, since this will warm up the plastic a little bit, it usually creates a little lip around the outside, so make sure you break that as well. Okay, as I said, there's a little bit of plastic right in here, so I'm just going to push the house. Okay, that should be it. Let's clean this up a little bit. Very good. Okay, now same thing for this. This is the lever. Now the way I print them is they're sitting on the build platform like this, and then this part, or little line, doesn't matter, like that. So it's printed up. So one side is going to be really smooth. That's the part that sits on the build platform, and the other one is a little uneven because that's where the printer stops. So make sure you just go through here, and especially around this is the ball bearing pocket, especially around this area, because this is the area that's going to make contact with this part up here. As you can see, it's already going in really nice. Just needs a little bit of cleanup, doesn't need much. Yeah, very good. And the same thing, break the edge a little bit. Just remove that edge that has formed on that lip. Okay. And now, very important, especially with this type of switch, the one without the lever. Every time I print this part, there's a little lip that forms right down here. This is where the ball bearings are going to go. And right in the center of that, there's a small line. I think you can probably see it on the video. It's right here. That needs to go away. Make sure this is really smooth. Because this is, if you look at the switch, there really is not much space here. So this needs to be all smooth and clean. Remove that. And when you do that, always turn the part around a little bit, because I'm holding it so I'm not applying even pressure. It's probably better if you put it in a vise and then apply pressure from the top evenly. Or just flip the part around every now and then. And then just feel it. Yeah, it's almost gone. Just this entire area should be really smooth. Well, mostly it's just, the switch is just sitting right here. But I just make sure the entire area is smooth. Makes it more even. Don't remove too much, because once you remove too much, then the switch can't be pressed anymore. So that should be it. And later on, once it's installed, you notice that the switch is not being released. Then you probably just need to remove just a little bit of material right here, and then there will be enough clearance for it to release. Just gonna clean up a little bit. Oh yeah, and then this right here, this is the magnet pocket where the magnet is going to go. So make sure you clean that out as well. I like to use a little knife for that. A sharp knife helps. Bill of material, what you need to build one of these units. You can find that on the project's GitHub page, again in the description below. But it's not much, just a few ball bearings, a few screws, magnet and a switch, and then of course the 3D printed part. Clean this up as well, it's already here. These are the mounting holes for the actual paddle. Okay, as I said, I've already done that to this part. It's the exact same steps, doesn't matter. Now at this point I'm going to clean those up real quick. I'm going to wash them underwater. There's a lot of plastic dust, and I don't want to get that get the dust into the switches. Here. Oh no, wait, one very important part. This here is the switch pocket, and let me turn that, there we go. There are little plastic dots in here. It's just left over from the printing process. Make sure you remove that, and make sure you remove them really well. The switch just sits in here. It doesn't have to be, it shouldn't be tight, because what I've noticed is if you have pressure from the sides, it sometimes interferes with the switch operation. So when it clamps in from the side, the switch doesn't release or it doesn't push properly anymore. It doesn't matter if it's sitting a little loose. Just make sure you have all this stuff away so the switch goes in easily. So let me just remove those little spots. And that depends on your printer. It's probably a retraction setting I could tweak to get rid of those. Or there's probably a little bit of slop in my belt. But it's just minor, you know. And it's only an issue with parts that are more precise. This is just the wire channel. Plastic here. And this is the other side of the magnet pocket. So I'm going to clean that out while I'm at it. See how that goes in. Oops, almost. Now, this type of switch will not go all the way in. It's not going to be flush with this top part, where this switch actually will be flush at the end. It's slightly angled, but when you push it in, it's flush. Whereas this one actually sits up a little bit. So, let me just make sure. No, wait, what was the front? That was binding. Yeah, and there's a little lip in here. We like just one layer that's sticking out a little bit, so the switch came down. Try. There we go. Now it's in. When you look from the front, it should be just slightly below this lip, this top lip here. This lip ensures that the lever doesn't actually hit the switch or the switch body, so it's going to be sitting just below that. Just looking good. So I'm going to go right back. I'm just going to wash them off real quick. I'll be right back. Okay, all cleaned up. And let's install the ball bearings. First, ensure that this hole is clear. This is an M2 screw. This is our axle, and yep, it's good. Now, the ball bearings, we're not using them properly in this part. Let me get one out. Okay, now usually when you, no, not usually, when you use the ball bearing properly, you have to make sure that the outside is going to be clamped in, and then you need to make sure that the outside is fixed, but only the inside ring can turn. It really doesn't matter much here, because we're not turning this hundreds of RPMs. We're only going to use it just forward and backwards a little bit. And all that it does, it just makes sure that, oh, stay here. Okay, let's go. It just ensures that we have a smooth contact point with our M2 axle. So these are just going to be on here. And metal on metal is much better than the metal on plastic. This binds, I've tested it before, and using the ball bearings makes it feel much better. Like I said, I'm also not going to install them properly. Usually you need to make sure that you don't put any stress on them. I'm just going to bang them in. I've been testing this for a long time, it makes no difference. Instead of using ball bearings, you could probably also use a steel tube where this will fit through. Maybe drill this out a little bit, force the steel tube through, and then you have the same effect, that the screw is not rubbing on plastic and slowing everything down. Now let me get these in. Something to whack it with. Still be careful when you install them, but like I said, this is not proper, but it has been working really well. Okay, make sure they're in all the way and it's smooth. Just turn around between middle and middle. Very good. And now the other side as well. That moved. Whoops. Back here. This is the side that was on the build plate. There's probably a little lip in here. It's preventing the ball bearing from going in. Just cut this open a little more. And these ball bearings, you can get them really cheap. You can get them on eBay or Amazon. The exact type of what they're called is going to be in the bill of materials. It's on the website. Just get that in there. This one is a bit of a pain. Usually they just go in. Let me cut that open a little more. Oops. Go. Good. Perfect. Make sure they're in all the way. Actually, that's a little more. There we go. Okay, now all this does, once the axle is in, it just gives it a smooth surface to ride on. That's all it does. Okay, let's get that back out. And for all my tests, I've been using the same two ball bearings. These are currently installed in this part, and they're still the same ones from the first original test, and they're still working fine. They probably won't be running in any kind of motor anymore, but for what we're using it here for, just fine, no problem. Okay, let me get this out. Now also make sure that the screw actually goes through, because when you print them, this hole tends to be a little bit too small, so also clean that up. And then remove any plastic that came out of the hole. And then definitely, let's press this in first. This is just an M2 nut. You probably want to get either use Loctite or get a locking nut. I've been using Loctite and it's been working quite well. And this just gets press fitted into the spot. Larger pliers. And the hole actually is a shape of a nut, so make sure you align the edges somewhat properly or you'll split the plastic, but the hole has the right size and the right shape, so if you just press them in carefully, nothing's going to happen. Make sure it's in all, well, mostly, but it needs to be straight. That's the important part. There we go. Okay, and now I would really suggest make sure the axle actually goes through. Test that before you try to install the lever. Get this one out of the way. Could probably also use a small drill to open the hole up a little bit, but don't overdo it, or you'll introduce wobble, or it may actually, the lever may then just be too low and hit the switch. So I just like to take my time a little bit, just do this once, make sure it fits, and then we can install the lever after that. Whoops. Yeah, this is also a good test because I've had an issue printing once and then this wasn't aligned properly. It was just an issue with the printer. So you can just test this out, make sure it fits. Yeah, see, now it's actually trying to push the screw out. Or push the nut out. Back the screw out a little bit. This is 3D printing, so there's a little bit of manual adjustment involved. Since the home printers are not that accurate yet, or at least mine isn't. Okay, let's do that again. Oops, come back here. Okay, let's try that again. The nut isn't. Oh no, now it's been caught. Okay. Back out. Okay, now with the nut back in place, let's install the switch next. I'm going to use the switch out of this part because I already have a wire attached to it, and I'll be using this unit for actual testing. Get the switch out. Now, the orientation is very important. With the this type of switch without the lever, the button needs to go towards the front, whereas with the lever type, the lever points towards the front and the little switch or the little button is towards the back. So it's very important that that little button is towards the front. Let me get this in. There we go, proper orientation. And since we've widened the pocket a little bit, it slides in real nice. Make sure the switch still works. Very good. Perfect. And now, at this point, well, actually I would assemble it first, but these are mounting holes down here. This is where you can attach it to your button box. You'd have to put the screws in first before you install this part, but this is for testing right now, or to show you on video. So let's get this in. Go. Oh, where is it catching? It's catching somewhere. Okay, now it's probably a good idea just shine a light through the hole so you get it aligned properly. I'm just going to hold it up to the light real quick. Okay, that should be aligned. Let's get the screw. Was that the one? Yeah, I think that's the one. Let's just get that in here. Very good. Oh, that's a bit too tight. Don't over tighten it because it'll just pull everything together and then the operation's not as smooth. Whoops, now I lost the nut again. Get that back in. Okay, nut is back in. There's a little bit of binding right here on this side, so I actually need to take it apart again and move a little bit of material here. Yep. This needs to be smooth or it's going to get stuck. There's a little bit of material left. So it's just over here. clean that up again and bring that back. Okay, let's get that back in. Yeah, it's just a little bit. Now it's real nice. Okay, so align that again. Let's see, where's the hole? There it is. That should do it. Perfect. You can probably even hear the difference. It's real easy to move now, and you can also, I don't know if you can hear in camera, already hear the switch clicking. So we're good on distance. So at this point all we need to do is install the magnets and we're done. Okay, now what I'll be using is one of these. This is a 3mm thick. These are a little thinner. I think this is just like a millimeter and a half. But the switch pocket can take up to a 3mm thick magnet, 12mm diameter. This determines how strong they are. So this just goes right in here. If this is too weak for you, you could add a thicker one from this side, but I don't really think it's necessary. Okay, let me, for testing, I'll just install one of the thinner ones right on top. Make sure you orient them the right way. I would suggest just hold them on top and just let it snap in. Now the magnets are not glued in place, they just attract each other, and that should be enough to hold them in. Just make sure. There we go. Actually it goes in. Oh, I chipped the magnet. Okay. There it is. Very nice, smooth operation. And at this point you just need to connect these two wires to your button box, these two wires, and you have a working switch here. Now the other type, I'm going to put this together real quick. Same thing, put the switch in after you've cleaned out the pocket, and then you need to do, the steps are the same. You need to remove a little bit of material here, I've already done that. And the same, these two parts, the lever, are the same. I've just printed a second one so I can actually show you on video. This just goes in here. Let me get an axle. And these are just M2 screws, 40mm long. Also it's noted on the bill of material what you're going to need. I don't think that's the line that's hitting the ball bearing. Look. There we go. Oops. That should do it. This one, there's no magnet on the bottom yet. Let's just get this in. Put a magnet down here in the bottom pocket. There we go. Same thing, very nice, smooth operation. Now at this point, you'd have, doesn't matter which way you want to go, they're both working the same way. What I would suggest is get a multimeter now and make sure that your switch is actually working. Well, you should have tested that it was working before, but I'm just going to show you real quick. So makes a connection. It's going to beep. So I'm just going to go onto the two terminals here. And as you can see, this is how it's supposed to. It returns really nice and fast. This is why you need to make sure that there's enough clearance and just move some material. It doesn't bind up. Always smooth return, very nice, fast, reliable operation. Now the switch engages about halfway down. There it engages, and there's still a little way to go. So I've been testing this, and this appears to be a really nice distance. Now on the project page, you will also find plans for the paddle. This just mounts below it. I'm not sure about the size yet, but this appears to be quite well, or correct. Now it's also pretty strong. I've ordered the OSW yesterday, so I haven't actually tested this on OSW, just on my G27 when I removed the wheel. There's a video in the playlist. We'll have to see. This is probably printed the way it looks like. All those round dots, that's air. This is printed with like 20-25% infill, maybe even less, and it's already a really strong part. So print this hot, this fuses the layers together, and then it appears to that we can just go with a completely 3D printed magnetic paddle shifter. So this is it. That's how easy it is to build one. There, like I said, there's going to be a little bit of manual work involved because you need to clean this up a little bit, but once you've had it cleaned up, you have a really nice working shifter. Really fast, very reliable, and you can adjust the strength by using different size magnets. There's actually a smaller or a thinner one in here, and it's already working quite well. So print, the STL files, also the source files, all the parts I design, I use SolidWorks. The object files for it also going to be on the GitHub page, so check the description. And if you have any kind of questions, contact me through my website. It's kaisersoft.net. There's also a link in the description below, or give me a shout out on GitHub. YouTube comment page works for small comments, but it's not going to be good if you have any questions, suggestions, or run into any kind of trouble. That's where email to me or using the bug reporting tool on GitHub is probably the better idea. So that's it for the magnetic paddle shifter. I'll be getting, depending on how fast shipping is, I should have my OSW by the end of the week. Once I have these installed on the OSW, I will post another video so you can actually see them in action on the final wheel. So that's it for now. Have a good one.